latest model or not. Some people would concern with that, even though they don't use the most of the functions provided by the product, but still they prefer the product to be the latest version or the latest model. So that's another issue, okay, in the top 10 attributes. So we see that the concept of reliability and maintainability come in rank number 2 and number 4. So that's pretty high. Okay. So now let's see specifically about the meaning of reliability so that we can capture the reliability. We can have see the explicit number, or like how we can define it specifically. Reliability is defined as a probability. Okay, so the range of it would be between 0 and 1. It's the probability that a component or system will function. Okay, for a given period of time when used under stated operating conditions. For this definition, we have to know more. We have to know about how to define failure of a component or system. Okay, what does it mean by failure? What does it mean by functioning? Okay, before we can find out the probability of the component or the system functioning. Okay, and also it's something to do with time, operational time. The time could be, the unit could be in hours, in days, in years. That's about calendar time, or it could be the clock time, or cycle time. Okay, that's something that is about the time. So it's depending on the system or the application that you focus on. Okay, so the unit of time would be just as you identify. Okay, and to capture the time that the system is functioning or fail, it has to be in a normal environment or normal performance. Okay, such as when it is normally used, the system or the component, it could not be in a like abnormal condition, like in a heavy load, or extreme condition, like with a very high temperature, or in a vibration condition, in a very high pressure condition, something like that. So the data, this information has to be at a normal condition. As we see the graph here, this is a typical reliability graph. You see that initially when the time is equal to 0, the system or the component has probability of functioning or reliability equal to 1, meaning that it's perfect. Ideally, it is perfect. Once it has been functioning, the reliability would be decreasing. So we see that the curve here is monotonically decreasing when the time goes on. Okay. So now we see the definition of reliability. The next one related to reliability is maintainability. It is defined to be the probability that a failed component or system will be restored or repaired back to a functioning state, okay, within a period of time. with some maintenance procedures. So if we can maintain, or there is some maintenance procedure for a system or a product, then the system performance would be increased. Okay. So now we don't see the relationship of reliability and maintainability yet. We see that they are quite different. This one involved with failed component. Once it fails, then how likely it can be restored back to the functioning state. Whereas the reliability is focusing on the probability that the system will function. Okay, will function. Okay, so both of the parameters can be used to identify the status of the system when it is functioning and when it fails. Then it would be belonging to the issue of maintainability. The next issue is about availability. Again, all of these issues we use probability and statistics to analyze. Availability is defined as the probability that a failed component or system is functioning at a given point in time when used under a certain condition. Okay, so now we see that the description of maintainability and availability are somewhat similar, right? Let's take a look at this picture, okay, which simplify a condition of a system that U stands for the uptime of the system. Initially, the system is functioning when the time is equal to 0. Okay, once it is used for a while, then it breaks down. So now it is at the downtime. D, that stands for the downtime. And after it is repaired or it is maintained, then it could be back to a functioning state again, back to the uptime here. And repeatedly, this can happen like a cycle, up, down, and so on. So we can simplify the concept. Let's say that the uptime are all equal, and the downtime are all the same for all the downtime, like this. Availability can be captured as the percentage that the system is at the uptime state. As we see that the summation or the average of the uptime, okay, over the average of the total time that we consider here, that's both the combination of the uptime and the downtime. Okay, that tells us about availability. Or we see here that this is mean time between failure. So it means that the time is when the system is functioning. Okay, that's the uptime. And the mean time to repair, that's the average time, the downtime. Comparing the value of the availability and reliability, the availability would be always greater than the value of the reliability, because for the reliability concept, we don't consider that the system is repairable. So once it fails, it's just all gone. It cannot be back. So the system